Our Tennessee State Standard is to describe the effect of dilations, translations, rotations, and reflections on two-dimensional figures using coordinates. And today we are focusing on dilations. Your lesson objective, I can find the coordinates of a figure after a dilation. And number 2 is to describe a dilation. So you'll need to pause the video and write that down. And tomorrow when we come into class, I will show you an interactive definition of the word dilation, and we'll also watch a math short on dilations. A dilation is enlarging or reducing a geometric figure to create a similar figure. So a dilation, unlike rotations, reflections, and translations, will change the size. So the two figures, the pre-image and the post-image, will not be congruent. All right, dilation with a scale factor of 2. Our rule is to multiply by the scale factor. So somewhere on your notes, I want you to write multiply, or write rule is multiply by scale factor. All right, so if we have A at -4, 4, if we multiply by 2, A prime becomes -8, 8. B, if we multiply -2 by 2, then B prime becomes -4, -4. And C, if we multiply 4, 1 by 2, C prime becomes 8, 2. Do not forget to write down rule is multiply by scale factor. All right, a dilation with a scale factor of 1/2. So now we're going to multiply by the fraction 1/2. So A is -4, 4. Well, what's half of -4? That would be -2, and half of 4 is 2. Then we go to B double prime. Half of -2 is -1, -1. And C double prime, half of 4 is 2. Half of 1 is 1/2, or 0.5. Triangle ABC has vertices A, 5, 8, B, 1, 2, and C, 6, 4. Give the coordinates if triangle ABC is dilated by a scale factor of 3. So the rule is we multiply by the scale factor. So A, 5 times 3 is 15. 8 times 3 is 24. That's A prime. B prime, 1 times 3 is 3. 2 times 3 is 6. That's B prime. And then C prime, 6 times 3 is 18. 6 times 4 is 24. Triangle QRS has vertices 2, -5, and R, 5, -3, and S, 1, -4. Give the coordinates if triangle QRS is dilated by a scale factor of 1/4. So 2 times 1/4 would be 2/4, which is 1/2. -5 times 1/4 is -5/4, or -1 1/4. R prime, 5 times 1/4 is 5/4, or 1 1/4. And -3 times 1/4 is -3/4. S prime, 1 times 1/4 is 1/4. And -4 times 1/4 is -1. All right, describe the dilation. Well, we can look at triangle ABC, and it's larger than triangle A prime, B prime, C prime. So let's name a couple of these points our vertices. So A is 0, 1, 2, 3, 4. A prime is 0, 2. So what do you think this scale factor is? What can we multiply A by to get A prime? And then we'll check it on the other vertices. So we would have to actually multiply by a fraction because it's getting smaller. So 4 times 1/2, 4 times 1/2 would give me 2. So let's see. B's coordinates are -1, 2, 3, 4, 5, 6, -6, 0. And C's coordinates are -1, 2, -1, 2, 3, 4, 5, 6. So let's see. Half of -6 would be -3. So B prime should be -3, 0. Let's write that down and count it out. -1, 2, 3, 0. Yes. And C prime should be half of -2 is -1. Half of -6 is -3. So let's count that out. -1, -1, 2, 3. So that is correct. So now, if we look at ABC, triangle ABC has sides of 8, 10, and 12. So let's highlight that. So 8, let's say that this is 8. Let me make the 8 darker. We'll go with a pen on it. So this is 8. This we'll say is 10. And the longest side we'll say is 12. So if we know the side lengths of one of the triangles, we can find the side lengths of the other triangle using the scale factor. So our scale factor on this was 1/2. So the lengths of triangle A, B, and C, half of 8 would be 4, half of 10 would be 5, and half of 12 would be 6. So that would be the side lengths of triangle A prime, B prime, C prime, just by using the scale factor. All right, here we have triangle ABC, and then the image triangle A prime, B prime, C prime, which is much larger. So let's pick a couple of corresponding points. So we'll do C because it's easier. So C is 0, 2, and C prime is 0, 1, 2, 3, 4, 5, 6. So it looks like the scale factor is equal to, what can we multiply by 2 to give us 6? 3. Let's check one. So if B is -1, -1, 2, 3, then B prime should be -3, -9. Let's check it. -1, 2, 3, -1, 2, 3, 4, 5, 6, 7, 8, 9. And it is. And if A is -1, 2, 3, 0, then A prime should be -9, 0. -1, 2, 3, 4, 5, 6, 7, 8, 9. And it is. So if our scale factor is 3 and we have side lengths of 2, 3, and 4, then the side lengths of ABC, we would just multiply the pre-image side lengths. So 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12 units. All right, and just a review, because we will be having a quiz on Wednesday over transformations. With translations, you count left for negative or right for positive for x. You count down, negative, or up, positive for y, and you add the translation to each of the pre-image coordinates. With reflections, you count to the x-axis, x or y-axis. You count to the axis, whether it's x or y, depending on what you're reflecting across. Then you count that many past the axis. As far as the rule goes, if you're reflecting across the x-axis, you keep the x, change the sign of the y. If you are reflecting across the y-axis, you keep the y, change the sign of the x. For rotations, if you're graphing them, you turn the graph as directed. However, it tells you to rotate 90 degrees clockwise or counterclockwise, 270 degrees clockwise or counterclockwise, 180 degrees. So you turn your paper or your graph as directed and name the coordinates, then turn your graph or paper back and plot your points. Your algebraic rule, 90 degrees clockwise or 270 degrees counterclockwise, you switch x and y, then change the sign of the new y. For 180 degrees, you change the signs of x and y. And for 90 degrees counterclockwise or 270 degrees clockwise, you switch x and y and change the sign of the new x. And that is the end of our lesson today. Have a great day, and I will see you tomorrow.